All right. So in an exam like this, we are going to be doing a lot of approximations, especially when we don't need calculator, when calculator is not allowed. So looking at this, but assuming a calculator is allowed, that is even make it a lot easier. I mean, if they said this on GRE, so calculator is allowed, but on GMAT and MMAT, calculator is not allowed. How do we go about this type of question? First, let's remember that 0.0012, this means 1 to 1 to down to infinity. So that is the meaning of this. But that is actually not enough for us to solve this question. In as much as approximation is concerned, 10 raised to the power 4 minus 10 raised to the power minus 10 squared, that is 10,000 minus 1,000, is still approximately 10,000. So we can actually approach this question by saying 10,000, 10 raised to the power 4 minus 10 raised to the power 4 minus 10. This is very small, so we can take it like this, times 0.012. 0.0, yes, 0.012. All right, 0.012. Then we can write this as 10 raised to the power 4 times 12 times 10 raised to the power negative 4. Remember, sometimes too we are confused how to do this exponent, but we can go back to the one we know. Since we know that 0.1 equals 10 raised to the power negative 1, and that means we counted 1. So when we count up to 4, like here, so when we counted 4 here, see the 4, that is 1 2 3 4, so that means it's 4. That is 10 raised to the power 4. So this, now we cancel this, so the answer is 12, approximately 12. This is correct. Next question. At a loading dock, each workers on the night crew loaded 3/4 as many buses as each workers on the day. If the night crew has 4/5, now so you think so this 3/4 versus 4/5, we can start writing, let's say night. So night, if you have 3 workers, and for 3 workers, so day 4 workers. Sorry, night, the rate is 3, day, the rate is 4, then times 4 workers are doing like this, which gives us a total of 12. Yes, a total of 12. And 5 workers are working this way, which gives us a total of 20. And that is a total, an output of 12 and an output of 20. The total output is 20 plus 12 plus 20 is 30. Output, total work. So the total work is going to be 12 plus 20, which is 32. But we are looking for the fraction that belongs to the day, which is 20 over 32. 20 over 32, then we start looking for how the answers appear. 20 over 32, 4 can go into 20 to give us 5. 4 can go into 32 to give us 8. So this is correct. In a weightlifting competition, the total weight of those two lift was 750. So we can say S plus Y. S plus Y is 750. And if twice the weight of his first lift, so his first lift, that is 2S. 2S is twice the weight of his if twice the weight of his first lift was 300 more than the weight of second lift, that is Y plus 350. Then we can say this is 2S. 2S minus Y equals 350. Then we can solve this simultaneously, right? So we can solve this simultaneously. So solving it simultaneously, how do we go about solving this? So how do we go about solving this simultaneously? So we bring this one here, bring back this S plus Y here. S plus Y equals 750. Then we can add. Y is going, if we add, because since they are the opposite signs, so we add 2S plus S is 3S. equals y minus y plus y is gone. 350 plus 750 is 350 plus 750. What is 350 plus 750 again? 300 plus 700 is 1000. 50, that is 1100. Is that? This one is yes, is 750. Oh, this is 300. I'm sorry. Oh, this is actually 300. This is 300. This is 300 and not 350. This is 300 and not 350. This is 300. Okay, this is still 750. This is correct. 300 plus 750. 300 plus 750 is 1050. Yes, 1050. 1050 divided by 3. What is 1050 divided by 3? We do know that 1200 divided by 3 is 1200 divided by 3. 1200, look at it this way. 1200 minus 150, that will give us 10, or that is give us 1050. So this one over 3 and also this one over 3. 1200 divided by 3 is 400. 400 minus 50. 400 minus 50 is 350. So S is 350. S is 350. A club collected exactly 599 from its members. If each members contributed at least $12, $599 and at least $12. So I said earlier, so in an exam like this, so we do a lot of approximations. 599, if you are looking at 599 divided by 12, so we can approximate this to 600, but we must know that so what we are calculating is not up to 600. 600 divided by 12 is 50, but since we approximated from 599, so it is not up to 50, but just very close to it. So this is correct. 49 is correct. If y is the smallest positive integer such that 3 raised to the power such that 315 multiplied by y, if y is the smallest positive integer so that 3150 multiplied by y is the square of an integer, then y must be what? First, let's remember that what they're asking here is what makes a number. What can we use to multiply a number to get a perfect square? Now let's take a number like 6, and the prime factorization is 2 by 3. So what number can you multiply with 2 by 3 to make it a perfect square? So that will be 36, because we need to complete this. So 2 squared times 3 squared. So we need to make this power raised to this power to an even number. So this will be 4 times 9, which is 36. Or let's say what we are going to multiply to 6 to make it a perfect square is another 6. But let's say something like 12. What will you multiply 12 to make it a perfect square? 12 is already 2 squared times 3 squared times 3. 2 squared times 3. So we need an extra 3. It means that 12, to make 12 a perfect square, we just need to multiply it by 3. In the same way, to make 3150 a perfect square, we need to put it in its prime factorization. What is the prime factorization of 3150? Again, the prime factorization of 3150 is 2 times 2 times 5 squared times 7. So 2 times 5 squared times 7. We get times, or will this give us? No, I think this will not give us. Let's see. So the prime factorization of 3150 should be so we need to get 315. What can give us 315? what can give us 315. Say about 2 is there. 2 times 3, 2 times 3 squared, that is 2 times 3 times 2 times 3, 2 times 3 times 5 times 7, 2 times 3 times 5 times 7, 2 times 3 times 5, 5 squared times 7. Yeah, that is the prime factorization of 3150. Yeah, if you want to remember how to do prime factorization, if you want to do this exhaustively, that is 3150. You start this way. You say 2, and what is half of 3150? Half of 3150 is 15. 15 plus 75. So what is 15? Yes, 15 plus 75. That is 1575. 1575. You now go with 5. You divide it until you get all the components. Okay. So this is the prime factorization. You see that 2 is not 2. We need to make 2 a square, and we need to make 7 a square. That means we need to multiply. We need to multiply by 2 times 7 to complete this a square and complete this one a square. So that will give us 14. If operation S, so that is the correct way of reading this. If operation S, so this is read as operation S. If operation S is the greatest integer less than or equal to S, what is the value of minus 1.S, 3.4 and 2.7? Remember that the question said the greatest integer less than or equal to S. So the integer less than minus 1.6 is minus 2. The integer that is less than 3.4 is 3. The integer that is less than 2.7 is 2. Minus 2 plus 3 plus 2 will give us 3. That will give us 3. So 3 is correct. Next question. So let's solve this. So this look intimidating first. So how do we go about it? But let's solve the let's clear the fraction first. Let's try and clear the fraction first. On clearing the fraction, we are going to have 4 minus s equals, that is when we cross multiply. 4 minus s equals 2s plus s squared. 2s plus s squared. Okay, let's now collect like terms. We better move everything to our right hand side, so that have 0 here. Start with s squared, then minus 3s, then minus 4. So you can now see that this whole thing is equals 0. So this is s. This is why do we? Okay, this is plus, because minus s plus 2s is minus s plus 2s. Minus s cross sign of equality becomes s. S plus 2s is 3s. You see that this whole thing is 0. Next question. So in the first week, Nancy served $1. In each of the next 51 weeks, she served $1 more than she had served in the previous week. So this is forming an arithmetic progression, and a type of arithmetic progression is something we can easily. So this is something we can easily solve using this. Sum equals n over 2 bracket a plus l. Remember, n is the number of terms. A is the first term, L is the last term. L is the last term. So let's continue. What is n? So what is n? So Nancy served $1 in week 1. Okay, so that is this. So in all, that is for the 52 weeks. 52 over 2 brackets, the first time 1 plus the line is not that is progressing 1 2 3 down to 52. That is, so this gives us 52. Now if we evaluate this, 52 divided by 2, that is 26. So at some point we are going to get 26 times 1 plus 52 is 53. 26 times 50, 26 times 53, and that will give us 1378. 1378. Remember, 6 times 3, that is 8. You know, this is something, and I believe this is something you can actually do. All right, and now this is a trapezium. This is a trapezium. So how do we go about this one? How do we go about this trapezium? First, a trapezium, the area of a trapezium is half. The area of a trapezium is half the two bases, half the two bases times the height. A plus B, that is the basis, times the height. Okay, but what are the bases? So we have the bases 2 and 5. Now what is remaining? What is remaining is we don't know the height, so we need to get the height. So is there any clue on how to get the height? The question said that AB is 13. So here is 13. So depending on so this is 13. Depending on your level of preparation for an exam like this, you must have encountered a Pythagorean triple that is 5, 12, 13. Since we are saying 5, 12, so the other one must be, we have seen 5 and 13, so the other one must be 12. Pythagorean triples. But how do we even get a triple like this? If you check 5 squared, 5 squared is 25. 25 minus 1 is 24. 24 divided by 2 is 13. So 24 divided by 2 is 12. That same 25 plus 1 is 26. 26 divided by 1 is 13. And you can follow that same process to get other triples. Okay, so let's move ahead. Now the area equals half the two bases, that is 2 plus 5, times the height. The height is times 12. Two can cancel 12. 12 divided by 2 is 6. So we end up having 7. 7 times 6. What is 7 times 6? 7 times 6 is 42. 42. Do we have 42 there? Yes, we do. Next one. Next one. In a certain sequence, the term S, in a certain sequence, the term Sn is given by the formula Sn equals 2Sn minus 1 minus half Sn minus 2. So if you are looking at this, so we are saying the term Sn is n minus 1. You know, n minus 1 and n minus 2. N minus 1 is the term before it, and n minus 2 is the term 2 position before it. That means, since, okay, again we are given S1. To get S3, we need S1 and S2. So we need the last two terms. So we are given S1. We are also given S0. So we can use S1 as S0 to get S2. So the first thing we do is to get, the first thing we are going to do is to get S2. So to get S2, so let's go and get S2 first. Remember that S2 according to this is S1, because it's same minus 1, or it's 2S1 minus half S0. Half S0. Okay? So now let's work it out. This equals to S1 is given as 2. That is 2 times 2. minus half. S0 is given as 3. That's half times 3. So this will give us 4 minus 1.5. 4 minus, what is 4 minus 1.5? 4 minus 1.5 will give us 2.5. We now go and look for the one the question is asking. The question is asking for S3. S3, which is 2S2 minus half S1. Half S1. So this will be 2 times 2.5. 2 times 2.5 minus half times 2. 2 times 2.5 is 5. 2 times 2.5 is 5. Half times 2 is 1. 5 minus 1 is 4. Is there 4 there? Yes, there is 4. Alright. That is the end. That is the end of this solution. Is there anyone I didn't solve? Let me know what you think about this question. Send me a message if there is anything you want me to clarify. We are going to continue with the next 10 questions. I know 10 or 11 questions. I know that people want to watch short videos, but at the same time, exam demands that you do more than short studies. So you solve more questions. Exam demands that you solve a lot of questions for you to pass, not just for entertainment, but also for learning. Both learning and entertainment entertainment and learning are both important. Thank you. See you soon.